We have given function f. We have to find the limits and we have to sketch the graph of function f. Before we do this, let's see our function. We have in denominator absolute value bars. So first we have to get rid of this absolute value bars. From definition, we have absolute value of x minus 2 will be equal x minus 2 for x minus 2 greater than or equals 0. But because we have x minus 2 in denominator and we cannot have 0 in denominator, so I have to exclude the 0. So the value x minus 2 will be greater than 0 only. So it means I can solve this inequality. It will be x is greater than 2. And when we get rid of absolute value bars and we have x minus 2 less than 0, we have to put negative sign before this whole expression between absolute value bars. And this will be x is less than 2. I just solve this inequality. So now we can go to our function. We can rewrite it f of x will be equal, and we will have two cases. First will be x squared minus 4 over, and we put x minus 2 when x is greater than 2, and the second case will be x squared minus 4 over, and we will put negative sign before x minus 2, and this part is for x less than 2. Now first we have to find right limit of f of x. So let me write this. We have limit as x approaches 2 from the right of f of x. This is equal limit as x approaches 2 of right, and we just have to put the first case because on the right side of 2 x is greater than 2, so it means we have to use this formula. So it will be x squared minus 4 over x minus 2. This is equal. We have x squared minus 4. So we can rewrite this. Let me copy the limit. As x approaches 2 on the right, we have x squared minus 4. We can rewrite x minus 2 times x minus 2 plus 2. I just use formula a square minus b square. The difference of square is equal a minus b times a plus b. So, and denominator we have x minus 2. Now we see that because we have multiplication in numerator, I can reduce x minus 2. So we have limit as x approaches 2 on right of x plus 2. Now we can just put 2 for our x because we have addition. So we have 2 plus 2 is equal 4. This is our limit as x approaches 2 from the right of our function of x, f of x. Now we have to find limit as x approaches 2 on the left side of our function f of x. So let me copy this limit as x approaches 2 on the left, and we are going to 2 on the left side. It means x is less than 2. We had to use this formula for our function f. So we have x squared minus 4 over negative sign, and in parentheses we have x minus 2. Again, I can rewrite this difference of square. So it will be limit as x approaches 2 on the left side, and in numerator I will use this formula, so it will be x minus 2 times x plus 2 over negative sign I have, and in parentheses x minus 2. X minus 2 I can reduce because I have multiplication, so I will have limit as x approaches 2 on the left side, x plus 2 over negative 1. So I can put negative before parentheses, and I will have x plus 2 inside parentheses. So now, because I have addition here, I can replace x by 2. So this is equal negative sign I just copy, and we have in parentheses 2 plus 2. This is equal negative sign, 2 plus 2 is 4. We have the left limit. The next question is, does the limit as x approaches 2 f of x exist? We see that the right limit and the left limit are different, because the limit f of x as x approaches 2 from the right side is different than limit of x as x approaches 2 from the left side. It means the limit as x approaches 2 of f of x does not exist. This is solution to B question. This was A. Now we have to sketch the graph of f function. Our function has two parts. We can reduce something because we have x squared minus 4. We can rewrite this to x minus 2 times x plus 2. So our function f of x, this is C question, will be equal x minus 2 times x plus 2 over x minus 2. This is for x greater than 2. And when x is less than 2, we have x minus 2 times x plus 2 over negative sign before parentheses, and in parentheses we have x minus 2. This is our f function. We can reduce x minus 2 and x minus 2 in both parts. So our function will be x plus 2 if x is greater than 2, and we have positive over negative will be negative x plus 2 in parentheses when x is less than 2. So we can rewrite this one more time. Will be x plus 2 for x greater than 2, and this negative sign change the sign in parentheses, so will be negative x negative 2 for x less than 2. So our function f has two parts. For x greater than 2, we have linear function x plus 2. The graph for linear function is straight line. And for x less than 2, we have linear function 2. So to draw the graph, we will need at least 3 points. So first, I will rewrite our function f to two functions. So will be f1 of x equals x plus 2, and the domain for this part is x greater than 2. And the second function, f of x, will be negative x, negative 2 for x less than 2. So let's choose x and calculate the value. The second row we will have f1 of x equals x plus 2. I have to choose x greater than 2. But like always, I will check what will be with x is equal to. So I will choose 2, greater than 2 will be 3, 4. And now when I replace x by 2 will be 2 plus 2. This is equal 4. And now I will replace x by 3. We have plus 2. This is equal 5. Now we have 4 plus 2. This is equal 6. So we have 3.24, 3, 5, and 4, 6. Now we have to do the same for the second part of our function. Have to choose the x, and x now has to be less than 2. So like before, I check what will be for x equal to. Value less than 2 will be 1, 0. f2 of x is equal negative x, negative 2. So now you replace x by 2. So it will be negative 2 is equal negative 4. Negative 1, negative 2 is equal negative 3. And 0 minus 2 is equal negative 2. So we have 3 points. 2, negative 4. 1, negative 3. And 0, negative 2. So now we have to draw xy plane. We have y equals f of x axis and x axis. I have to choose the unit. Negative 1, negative 1. And first we will find the points for first part of our f function, f1. So we have point 2, 4, 2 and value 4, 3, 4. Let's disconnect. So this is our first point, and because x must be greater than 2, so I will draw circle. Now this is 2, 4 points. Now we have point 3, 5, 3, 5, and 3 belongs to domain our function. This is point 3, 5. Next we have 4, 6. Point 4, 6. So we can draw straight line because we have linear function. The graph is straight line. X is greater than 2. It graph going to positive infinity. Now we have to find points 2, negative 4, 2, negative 4, negative 2, negative 3, negative 4. And because x is less than 2, this point is not included in our graph. This is 2, negative 4. Next point is 1, 3. 1, negative 3. we have 1, negative 3, and the third is 0, negative 2. 0, negative 2. And again, because our function is linear function, the graph will be straight line. X is less than 2, so let's check one more time. First part of our f function is x plus 2, linear function, and the coefficient before x is positive, so our line should increase. Let's see, this part going up, it means increase, everything is okay. The second part of our f function is linear function too, so the graph will be straight line, and we have negative coefficient before x, so our line should decrease. Let's see, we're going down, so everything is okay. This is our f function.